Hello everyone, welcome to Ganit Online. So we are going to learn about the topic condition for concurrent lines or condition for concurrency of three lines. So here the theorem states that L1 a1x plus b1y plus c1 is equals to 0 and L2 is equals to 0, which is a2x plus b2y plus c2 is equals to 0, and L3, which is a3x plus b3y plus c3 is equals to 0, are the three straight lines. These are the three straight lines, no two of which are parallel. Then the condition for the lines for the concurrency is that sigma a1 of b2 c3 minus b3 c2. So this is the condition we have to prove. So given that these three lines are concurrent, so then we have to find out the condition for concurrency. So here I have already written these things. So because we have already discussed, so this is the line L is equals to 0, this is L2 is equals to 0, and the point of intersection of these two lines is, I have written the coefficients of see B1 first place and C1 and A1 and again B1. So B1, C1, A1 and B1 in the same B1, C1, A1, B1. The same way for the second line, coefficient of y, constant term, coefficient of x, again coefficient of y. So x, y and 1. So x by, we have to go in this way, b1 c2 minus b2 c1. So x by b1 c2 minus b2 c1 and y by c1 a2 minus c2 a1 and constant 1 by a1 b2 minus a2 b1. And then after this you just transfer this part to here, and then we will get x comma y is equals to b1 c2 minus b2 c1 by a1 b2 minus a2 b1 and comma c1 a2 minus c2 a1 by a1 b2 minus a2 b1. So this is the point of intersection. Then so clearly it is understood that L3 also passes through the point of intersection. L1 is equals to 0 and L2 is equals to 0. So this L3, so this point of intersection, though this point is being satisfied by the equation L3 is equals to 0. So the point of intersection passes through the line, passes through the line L3. So yes, and then so we have to substitute this point. Okay, so I am writing the L3. L3 is equals to a3x plus b3y plus c3 is equals to 0. So what is a3x? A3x is what? b1 c2 minus b2 c1 by a1 b2 minus a2 b1 plus b3 times of what is y? c1 a2 minus c2 a1 by a1 b2 minus a2 b1 plus c3 is equals to 0. So let us simplify it. a3 times of b1 c2 minus b2 c1 plus b3 times of c1 a2 minus c2 a1 plus c3 times of a1 b2 minus a2 b1 is equals to 0. So this is nothing but sigma a1 times of b2 c3 minus b3 c2 is equals to 0. So this is the condition for concurrency, hence prove. Note, what is the note? So if the three lines are there, directly we can find the condition. So the condition is determinant of the three lines. So coefficient of x or the first line, coefficient of y and constant term c1. The same way a2, coefficient of y2, second line and constant of this one, and next a3, b3, c3. This is equals to 0. So this is the condition for concurrency. Condition for concurrency of three lines. So you will be learning about this part in the second year, in the senior intermediate. So you, as of now, you just understand that the determinant is 0. So I will be explaining how it is done. So a1 times of a1, I will be writing here a1. So you just, so in this way a1 times of, so b2 c3 minus b3 c2, a1 times of b2 c3 minus b3 c2 minus, y minus means this is a cofactor, you as of now just remember that alternate plus minus. So yeah, in this way, and this comes and this one. So these three, a2 b3 minus a3 c2. Yeah, so this is minus b1 times of a2 c3 minus a3 c2, and again plus similarly plus c1 of a2 b3 minus a3 b2. So this is equals to 0. So on simplification, clearly it is understood that a1 of b2 c3 minus b3 c2 is equals to 0. In competitive exams like MSET, Mains and JEE Advanced, directly we will be using the determinant to find the concurrency. So that's it in this video. So what we have learned, the condition for concurrency of the three lines we have learned, and we have proved the theorem. So for more interesting videos like this, so if you want to learn more concepts for the junior inter and senior inter, so subscribe to our channel Ganit Online, and you share it with your friends. Thank you for your time. Thank you.